Now it's your turn to try this example. Complete the table by finding 3 solutions to the equation y equals negative 2x plus 1, and in part B, plot those solutions on the graph. If you have not done this one already on your own, please stop the video, complete this in your lecture notes packet, then return to the video to check your work. To begin finding 3 solutions to that equation so that we can complete the table, we need to either begin by picking an x or a y value. Since this equation is already in the form y equals something, it is already solved for y, so our work will be simpler if we begin by picking values for x. The choice of values that we pick for x will be completely arbitrary, so as I begin picking 3 values for x in this video, they may or may not be the same as the values you have already chosen in your work. While the table we create for part A might look different, when we go to plot these solutions, we will always end up with the same line, assuming all the work has been done correctly. As a starting point, I will pick an x value of 1. So in picking x equal to 1, I will substitute 1 in for the x in the equation, so the equation now becomes y equals negative 2 times 1 plus 1. Continuing through with the arithmetic, negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. So we know the y-coordinate is negative 1 if the x-coordinate is positive 1, so our ordered pair, our solution, is 1, negative 1. For a second x value, I will pick 3. By setting x equal to 3, our equation y equals negative 2x plus 1 becomes y equals negative 2 times 3 plus 1. So y equals negative 2 times 3 is negative 6, and negative 6 plus 1 is negative 5. So we know the y-coordinate that corresponds to an x-coordinate of 3 is negative 5, and our solution is 3, negative 5. For the third and final solution that we need to find, I will pick an x value of negative 2. In picking x equal to negative 2, our equation then becomes y equals negative 2 times negative 2 plus 1. Negative 2 times negative 2 is 4, and 4 plus 1 equals 5. So we have a y-coordinate of 5 if the x-coordinate is negative 2. We have the solution negative 2, 5. Now that we have our 3 solutions, we can begin graphing our line, but before we do that, we again need to set up the axes. We first need to draw on the x-axis using a ruler. We need to draw on the y-axis, also using a ruler. We need to make sure we put arrows on at least the positive ends of the axes, as well as label the axes, x and y respectively. And again, we need to set a scale so we know how the spacing on these are set. Before setting the scale, I always look at the values I'm working with. I can see on my graph from the origin to any edge has 6 spaces, and all the numbers I'm working with fall between 1 and 5, positive or negative, so I know a scale of 1, 2, 3 will also work there. I might decide to set the scale on the graph instead of writing 1, 2, 3, just writing 2, 4, 2, 4 on both the x and the y positive sides, and then negative 2 and negative 4 on the negative side of the x-axis, as well as negative 2, negative 4 on the negative side of the y-axis. This way, there's enough information so somebody can read the graph, but it's not too much information where it becomes a distraction. As always, you'll want to check with your instructor as to what the requirements are for setting the scales on the axes and the graphs for your class. To now begin plotting the 3 solutions, starting with the first one. To plot the solution 1, negative 1 as a point on the graph, we'll start at the origin. An x value of 1 means go to the right 1, and a y value of negative 1 means go down 1. So that gives us the point here at x value 1, y value negative 1, or 1, negative 1. To plot the solution 3, negative 5, we again go back to the origin. An x value of 3 means go right 3. A y value of negative 5 means go down 5. And that gives us our second solution at 3, negative 5. Once again, starting at the origin, we now want to plot negative 2, 5. So an x value of negative 2 means from the origin go left 2, and a y value of 5 means go up 5. So we have our third point, negative 2, 5. With these 3 points being somewhat spread out, it's hard to tell exactly for sure if they are or are not on the same line, so this is where your ruler will become crucial. If we line up a ruler against those 3 points, it does become clear that they are on the same line, and so we do have 3 correct solutions for this equation. We'll finish this by graphing the line, meaning drawing on the edge of the ruler, to visually designate where all the solutions for this equation are. Once we've removed the ruler, we will again add the arrows to both ends of the line we've just drawn to represent the fact that this line does go on in both directions forever. There is no end to the solutions for this particular equation. Again, it's important to emphasize the fact that this line represents every solution to that equation, and every solution to that equation will fall somewhere on this line. If we were to pick a point on this line, say here on the line we see there's a point at -1, 3, -1, 3 will be a solution for that equation.